my name is Anders Näsman. I work for Akamai Technologies, and today's lightning talk is about common access tokens. So we have Will. He's using a login form to log in to his favorite VOD service. The VOD service returns a token. Will's player amends that token as a query string, a header, or a cookie, and sends it to the CDN for verification. If the token is verified, it returns the media back, and it can also renew the token, meanwhile sending media back. This is all well, but a recent study shows that 35% of all media services are using multiple CDNs, and almost all CDNs has their own proprietary tokens. So if you create a token that will fit one CDN, it's not necessarily working in another CDN. In 2021, the Wave Group started the work on creating a standard for media tokens. This standard has emerged as Common Access Tokens, or CAT for short. Some of you may have worked with JSON Web Tokens, JWT tokens, or JOTs. They're built using JSON format to incorporate what's called claims. Claims are rules that should be fulfilled for the token to be valid. CAT is similarly constructed using JSON, but instead of using raw form JSON, the payload is compressed using CBOR, where the claims are represented by numbers. While a JWT token consumes 208 bytes, the same payload inside CAT consumes only 35 bytes. CAT supports many types of claims, including most of the common claims also found in JWT, like subject or expiration. CAT also has its own claims with a clear focus on media and can, for example, include geographic locations. CAT also has the ability of conditional claims, like if you're climbing Mount Everest from the last base station in Nepal, the claim could look like this. So this was a super short summary of common access tokens. Now I have some actions for you. First of all, check out the links up there. Secondly, talk to your colleagues about common access tokens and how they have implemented it. And third, have a really great rest of Demuxed.
Hi, Steve Heffernan here. In case you've blocked it out, I've been talking about web components and video players since the very first Demuxed back in 2015. So this makes it a good year to kind of wrap up that conversation and cut myself off, and in case you guys don't do it for me. It's been really great to see the uptake and the adoption of web components in web players from groups like Apple and BBC and TED. And if you're working with web components today, I'd love to chat with you. But I think after 10 years, I finally understand, like at the root of myself, why I've been so passionate about this space. And it comes back to my experience with Video.js and building Video.js. And you probably recognize the controls of Video.js because no one ever styles them. Myself and the other Video.js contributors put a ton of effort into the CSS and the JavaScript components to make it really easy to style and customize the player. And Video.js itself started as a tutorial for how to build controls because I was excited for myself and other people to build interesting video player technology and UI specifically using web technology. But now it's on a million websites now, and it's almost always the default controls. You can go to Amazon.com and watch a product video, and you'll see what I mean. I've even seen it on the back of a United Airlines headrest with the default controls, and it's really depressing at the end of the day. I was talking to somebody from JW Player last night, and it's a similar story over there. With that, then, meet player.style. It is a set of open source themes for any web player, for any web framework, built on web components, and even more removing the hurdles and difficulties of styling your player, with the goal that you would do that. We of course have lots of pretty themes, lots of themes that you can start with and default with, and of course have to have a Winamp theme. You just gotta have that. But I think probably my favorite part of the site is this UI here, where you can pick from any player to use with the theme. You can pick from any framework on the web to use, and we're of course adding more all the time to these things. But better than any talk that I've given in the past, I think this UI shows off the flexibility of web components that that web components brings to video players and the video player ecosystem. Because all of this just kind of works out of the box, and we don't have to do a ton of effort outside of building web components and building light wrappers around them. So, simply with that said, the next time you're building a cool video demo or for a talk or something else, instead of just using the default controls, I encourage you to pop over to player.style, pick a theme that you like, maybe customize it a little, and if you have feedback for us, please let us know. And of course, if you want to build a theme and contribute it back, I would love to help you do that. Mediachrome on video dev and at Hef, and thank you very much.
Hey, today I'm going to talk about the open source multimedia community and the usual updates I do every year. So for those who don't know me, I'm the president of the Videoland nonprofit. I'm active in several projects like FFmpeg, X264, David, of course VLC, and I run several companies around those open source communities. I'm back after 1 year. Last year I was promising that we would release 7.0 in the spring. We did. We also released FFmpeg 7.1 a couple of weeks ago. We have released versions of David as usual and VLC and other open source projects. So I'm going to explain a bit what we've done lately. So FFmpeg 7.0, which was supposed to be out in February, got out in February late, which is April. Like one day, in the past, we didn't do any releases, right? So we're getting better. Big things about CLI multithreading, which is important. A lot of things on AV1 hardware decoding, a lot of optimization on RISC-V, and a lot of API breaks that you all love. You're welcome, you're welcome. It's a large release, but it was fundamental because of the work that was done on multithreading. So the FFmpeg CLI is used literally everywhere. It's badly used everywhere also, yes, we know. It's very flexible. It's so complex that you need several AI tools to be able to write correct command line supplies. Yes, some of you are also writing guides on that, but also the architecture was back from 2000s, right? And the lack of multi-threading was a problem because when you do complex ABR, you were waiting for several filters to be done, so we started doing that. It was a major work, mostly done by Anton. You should really watch the talk from Anton at Last VDD about that, but that was mainly. 7.1 was released a few weeks ago. It's as I said, a ton of codec, a fuck ton of codecs, VVC, LCVC, MVHEVC, XHEAC, IMF, DVD support, a lot of things on cell safety, ARM, and it's a large thing, and it is an LTS release. You should use that one. It's going to be supported for 3 years. Other Videoland projects, a lot of releases on David, a lot on David 1.4 in February, and 1.5 literally today after that talk. I will tag it. I promise a lot of things done on optimization. Again, more assembly. We're probably at 250,000 lines of handwritten assembly. I lied last time saying that we were the fastest. We are still even faster. A lot of things done on .prod, IMA. We've done some R&D on offloading some stuff on the GPU. So use David, it's used everywhere. A lot of things on VLC, the same, mostly 3.0, VLC 4 is not out yet, soon, but a lot of things on 3D engines and immersive versions of VLC, mostly for the Apple Vision Pro. We're an open source community, we are volunteers, we need money, we need support. Don't be like WeChat, hacked because they couldn't update FFmpeg because they use a version from 5 years ago. Thank you for YouTube and Meta who sponsor that, but you guys, your companies should be there next year. Help us, we need you. Thank you.
Hey everyone, my name is Phil. I'm from AWS Elemental, and don't worry, I'm very good at getting things done in 3 minutes or less. So I'm sure you've all seen this architecture diagram before, but just to run through it very quickly, this is a typical kind of live event production workflow you would see. You would have an on-the-ground encoder, you would have a cloud contribution, a cloud distribution encoder, a cloud packager, and then an ad insertion layer then delivered by a CDN. But if you wanted to insert an ad, if you wanted to insert an ad, then you have to wait for that ad to propagate through all of those systems. And then by the time it gets to the actual ad insertion layer, the load on the ad server looks something like this. It's a huge spike and idle otherwise. Now, if the ad server has some kind of limit onto the load it can take in terms of requests per second, then you might cap out the number of transactions you can hit, which ultimately affects the actual monetization you will receive as a stream provider. So wouldn't it be nice if you could basically hint to the SSAI system that there's an ad break coming up? Typically, the production will hit a button that says there's an ad coming up in 3, 4, 5 seconds, and that's Scuddy pre-roll, and then you have the time it takes for that to propagate through the system. So it looks something like this. You basically send it over, and then while it's propagating, the ad server can go off and make a smoothed out sort of set of requests to the ad server, and so your load looks something like this. Very pretty graph for people who work in distributed systems. And so there's a few ways of doing it. The way at the top is the way we support it today, but the ways below are interesting new ways we could work with HLS interstitials. Because the HLS interstitial tag is decoupled from any kind of segment, it means you could instantly insert that date range tag with the interstitial class the moment the production signals that the ad is coming up. And you could use that to your advantage to then have an input into the SSAI system to retrieve those ads for viewers who are currently streaming. With MediaTailor, which is the product I manage, you can actually create these prefetch schedules today. And so if you were to translate that Scuddy pre-roll into a prefetch schedule on MediaTailor, you could do it today. And in fact, that would be the best way, because you could, on the production side, at the same time you're inserting an ad on the encoder, you could be sending this call via JavaScript command to the API endpoint on MediaTailor. And example with interstitial, if your packager or your encoder outputs interstitial date range tags, you could have the start date appear as 8, 10, 15 seconds in the future. And if your SSAI platform can read that, basically the moment it's created, it can also start doing those prefetch commands. And with that, just a few takeaways. Thank you very much for your time.
Okay. Hi, I'm Vittorio. I'm here to talk about accessibility and sign language in particular. The fundamental problem of accessibility is that we all know that it's an essential element for any multimedia application and program. However, it's not as cool as other topics like AI, for example, and it's not as remunerative to other topics like advertisement. So it's hard to get the proper investment to create something new in this space. My idea was that I'm going to propose to show you today is using elements of both cool fields to create something new and innovative and cheap for everybody in 3 minutes. So there are a variety of ways you can supply accessibility to your audience. I'm going to focus on sign language, which consists in translating the audio of the video into a sequence of signs that can be interpreted by hearing impaired people. There are currently a lot of blockers for a wide adoption of sign language streaming, mostly because you need a separate production to generate the video with an ASL interpreter. There is only a limited number of ASL interpreters available, so you cannot do it at scale. And then how do you stream it? How do you synchronize the video? Do you do a full composite? Do you do half layers? That's the idea that came from the advertisement. Well, my idea was trying to sprinkle some more AI on the already AI-focused transcoding pipeline like this one. Once a user uploads a video file, we usually generate audio transcription from the audio stream, and we generate the captions, and optionally we also translate those captions. What if we also translate the ASL to ASL? And there is a way we can do this, and it's not black magic. Something you can do right now. It's called hem sign, and just by converting text to feeding text to this model, you can generate an avatar that moves according to the alphabet, the hem sign alphabet that you can see in the middle of the video. Once you have this list of movements, you can easily instead of encoding a video, you can just feed these elements to a browser component, like for example WebGL. You can capture any kind of you can make any kind of animations to the that will animate on the browser itself, so you won't have any problem in streaming. And there is a big effort from the VR world where a lot of accessibility and ASL communities exist. In particular, this is just an example of your chat avatar that can fully represent a ASL stream. And yeah, thank you so much. If you have any idea or way to convert, thank you. Let me know.
All right, thank you so much. My name is James Broberg. I'm founder and CEO of Streamshark. And today I'm here to talk to you about the VideoJS VR project 10 years later. So I was at Demuxed 2015, 10 years ago around about this month, introducing the VideoJS VR plugin, which is a way for VideoJS to play back 360 content on VR devices and mobile devices in a responsive way. And I also talked about the incredibly expensive and inconvenient ways to capture 360 content at the time, most of which don't exist anymore, and the equally inconvenient way to play it back on a variety of janky devices and cardboard playback mechanisms. So 10 years is a long time. There's a lot of history to get through, but the cliff notes are sort of here. So we originally did the implementation back in 2015 as an open standards way to play back VR content on a variety of devices using the WebVR standard that existed at the time. It was fortunately adopted by the parent organisation at VideoJS as a first-class citizen, as a first-class plugin in the wider ecosystem. And then various improvements followed over the years to support a whole bunch of new projection formats that can do things more efficiently or more immersively. But the reality is, in the last 3 or 4 years, the project needs a fair bit of love, to be frank. That's from all of our contributors, us included. So the sands have really shifted beneath us in terms of the standards and best ways of projecting VR content to VR and XR devices. So the VR standard is now really the Web VR standard is now the Web XR standard, and effectively the plugin doesn't really work that well under modern devices. And there's a whole new set of standalone devices that we need to support and a whole lot of patterns that we need to support in terms of getting in and out of immersive modes. So in terms of why you should care, there's a surprisingly large number of headsets that are out there. So Meta's certainly sold a whole lot of headsets. It's not mobile phone pervasive, but it's gaming console levels of pervasiveness in terms of the number of units that are out there. And we expect a whole lot of units to come out from a whole different bunch of manufacturers, either licensing the headset OS or coming up with their own ways of doing things. Of course, very notably, the Apple Vision Pro has come out, and while extremely expensive for what it is, it's very impressive, and it's also now supporting the Web XR standard, which is a big boost. And there's other players entering the market as well, so we're really seeing a renewed interest in the space, and that's really something that we focus on here at Streamshark in terms of the workflows that we're offering, in terms of getting that content processed and onto the devices and playing out successfully. So in terms of what we've done, we've reforked the project. We've rewrote it in WebXR to support these latest emerging standards, and we've just done a bit of an uplift of the UI to offer immersive ways of consuming, entering and exiting those immersive modes. We're really just trying to laser focus on a smaller set of devices and uplift the quality. So there's a lot of ways you can help. You can check that out here. The UI needs a bit of love. There's more efficient ways of doing things, and there's new devices that we need to test it on. So get involved. We've been fortunate to have Colleen help us out, getting feedback from the Meta browser team in terms of optimizing the implementation with WebXR. So later this year, we expect to be featured as a reference platform in the open video pipeline, as well as a whole bunch of documentation that's coming out. So thank you.
Hey. Hi, everyone. My name is Victoria Tezoa. I'm with Alicart, where we specialize in live streaming monitoring. And also, I'm a member of Women and Streaming Media, where we are working to amplify women, female voices in the industry. So today I would like to raise a question if we need to decrypt or not to decrypt, and how to balance quality of service, quality of experience in OTT monitoring. Let's imagine that we live in a perfect world where we have an ideal scenario where we have access to everything, to the entire network. We can access every single probe and gather statistics from the entire network, starting from the from the CAD end and down to the regional edge server. But the reality that we are not in a perfect world, and sometimes we cannot get an access to some kind of pipelines. So let's say it can be an external CDN management managed by external providers, limiting monitoring capabilities, the DRM protected streams when you have no access to video, or limitation in hardware resources, or challenging in monitoring quality of experience for OTT compared to UDP delivery. So what you can do here is, based on our experience, you can track quality of service, quality of experience on the head end before and after transcoder and a packager points, and then just track quality of service parameters. So this approach, it can help you to save money for a server because you do not need additional hardware for decoding. And also this approach minimizes your challenges with integration, let's say, and also thanks to HTTP, quality of experience is not necessarily to be monitored here. Here are some common OTT transport errors, which are manifest download failure, an unknown manifest, static manifest, or incorrect segment size. There can be also some more transport level quality of service parameter that you can track, obviously. And the conclusion is that you can focus on transport level quality of service parameters, which can be an alternative for ensuring service quality. Thank you.
Hey everyone, thanks. So it's me again, inviting you all to come to Montevideo in summer. But our summer, is in January, because we're in South America. So I'm JP, I come from Uruguay. Uruguay, the one that Will mentioned yesterday in the presentation. Thanks, Will, for that. Many people don't know. And actually, we come from Montevideo, which is the city name, the capital city. It's not that we made it up. We have the Montevideo Tech community there. We host the Mata Talks. And we're hosting this event for the first time, which is the Summer Camp. So what is it? It is a different way to collaborate, to connect. And we have two different threads. And these are pictures from the last couple of years. So yeah, it's a lot about culture and food. So we have these summer projects that is two open source initiatives that we collaborate on. But the idea of collaborating is that the community proposes what we should work on, and then we actually put some of our developers from Qualabs, the company I run, to work on those open source projects that really make any sense to the community. And this year we got a lot of proposals. So all these people here, thanks to all the work from Nico, proposed different projects. And so thank you all very much. It's been really tough to pick 2 out of these 15 different proposals in the end, or 14, I think, because it's 12 people that more proposals. And these were the 2 selected projects for this year. We're going to be working on a project proposed by Mike English on a media over quick player. And then we're going to be working on a VAS to SGAI conversion service proposed by David Hasun, who couldn't make it to Demuxed because he was a father last week. So cheers to him watching online. So if you want to collaborate, if you want to be part of this, you don't have to go to Uruguay. Actually, in November, we're going to start contributing and working on the technical sessions. So reach out to Nico, who's over there, and let him know if you want to be a part of it. Many people from the community are already contributing. And of course, we have the summer week. So it's going to be last week of January this year. It's 1 week in Montevideo, cultural activities, working remotely, technical sessions. But don't ask me about it. Ask people here. So maybe you know Alex Zambelli or Babesh Abdaya, or you know Barry Owen, Casey from Paramount. They all came last year, so ask them how it was. And actually, in my opinion, it was amazing. And Casey is coming back. So we already have 5 people confirming they're coming this year. Thank you all. Thanks, Steve. Steve's coming for a full month with his family. He's crazy. Henry here, Casey, JT, and Juan Manuel. So if you want to know more about it, scan the QR code, let us know, reach out to us. We're more than willing to host you in Uruguay and to welcome you to why you should come to Uruguay next summer. Thanks.
All right. I didn't really have time to prepare any slides, so I just downloaded some random video of the internet. Can't remember something, large, fat, rabbit. Doesn't really matter, nobody will know it anyway. Hello, my name is Christopher, I work for Dolby. And today I will be talking a little bit about how you can show server-side ad insertion, or like the industry, as the industry likes to call it, SGAI. The industry really loves its acronyms. And imagine my disappointment, no AI involved whatsoever. So, how do you explain to someone server-guided ad insertion, especially someone that's not technical? Well, the best way is to kind of show them. So, what I tell people is you can be the G in SGAI, like the G. You can go all sugar babes all up in this place and just push the button and, you know, let them know. Okay, confession time. I lied to you. This was not a random video from the internet. It's actually Big Bug Bunny. I saw like 1 or 2 people recognize it. So what I had up here was just an HLS stream of Big Bug Bunny, and we added a component in front of it. And what it does is it takes the playlist, it intercepts it, and it adds data when needed. When I push this button, it adds, this button will do a post request telling this component, I want an ad for 10 seconds. Playlist will be edited, an interstitial will be added with the necessary data, and the player will do all the AI, not artificial intelligence. Sorry for lying to you all. Thank you for listening.
Hello, I'm Thomas Dady, and I'm going to talk to you about, as you said, immersive audio with IAMF. But before I talk about IAMF, I have to first go back and go into the history of audio. And back in the old days, we had it really easy. We had only one speaker, and that was enough for everyone. Unfortunately, humans have 2 ears, which means that pretty quickly people wanted to send a different sound to both ears. And so people came up with all sorts of funky ways to get that audio into both ears. Even harder for us is that not only do humans have ears, but they also have a brain in between those 2 ears. So they can also hear sounds from all sorts of different directions, from the front and back and all sorts of that. So what people started doing is they created 5.1. So we had speakers in the front and in the back, and you could localize audio to those speakers. Of course, with 5.1, you're limited to only hearing audio from those locations. So what do you do if you want even more directions? You can't just like keep on adding speakers forever. Wait, yeah, you kind of can. But eventually that hits a limit, and if you want something more flexible, there's an alternative. And to see that alternative, we can go back to the original phonograph. One thing they did that was super clever on records is that they made it backwards compatible. The audio for the left and right is combined to a sum, that's the mono mix, and that moves the needle back and forth along the record. But the sum and difference is encoded vertically. And so that's basically encodes the left and right difference measurement that allows it to be backwards compatible. And we can basically take this idea and extend it into all sorts of dimensions. So we could say the difference between the front and back, or between the top and bottom. And that's this, and we can keep on extending that down into sums and differences of smaller and smaller sections. This is called spherical harmonics, and when it's applied to audio, it's called ambisonics. You can actually encode this today if you want. You can encode Opus or WAV files into MP4, which allows you to encode this. However, this still might not be enough for you. For example, what if you want to do FLACs that are ambisonics? Or what if you want to combine a 5.1 bass layer with extra ambisonics to handle those extra speakers you might have? Well, there's a solution for that. It's called IAMF. It's a standard by the AO Media. I was chair, but a bunch of other cool people did the actual standardization work. This format lets you encode existing formats like AEC, LC, Opus, FLAC, and WAV into a container, which is then contained again inside an MP4. So it's a container within a container. You can use this, create that right now with IMF tools on GitHub. You can also do it with FFmpeg with the stream groups feature. As you can see from the command line, it's a little bit hard to use. You can use an API. or you can use FFmpeg to convert like an IMF FLAC to IMF Opus. So I hope you have fun with this. Go try it out. I look forward to seeing what you all create with this. Thank you.
Hello, I'm Alex from Philo. So we're very much interested in how our users are watching and looking at QoE and different types of KPIs. And one of the things that we noticed that we were looking at is here the hours watched per user were very different for two different platforms, Roku and Samsung. So Samsung on the bottom, Roku at the top. So that's really weird. Why are our users watching live TV have such drastic different watch behaviors on two different platforms, which should be pretty similar? They're both in people's homes, they're living room devices. So what's going on? One key interesting difference is, Roku is a native platform. Samsung, on the other hand, is a web-based platform, runs on top of Chromium. So, that's one interesting difference. And so a ton of debugging, a lot of hard effort, probably the more interesting part, but really hard to share, and diving into heap dumps and things like that. This is kind of where we landed. And for a little bit of context, so at Philo, we do live TV, video on demand, and so a lot of our users are watching long sessions on their Samsung devices of live TV programming. And we also do dynamic ad insertion as well as client-side beacon firing. And beacons are, are not in our same domain, so they're cores and cross-domain requests, and so that's kind of one key interesting difference. And so after a lot of trial and error and trying to look at things, we kind of narrowed down to this snippet of code that you see here. So basically the problem was in our ad subsystem where we were firing these beacons, and there's quite a bit of them. Every ad has 20 plus beacons with different quartiles and completions and different parties interested. And then there's, countless minutes of ads. So there's quite a lot of beacons getting fired. And so what we noticed was that, critically, that, mode no cores, we narrowed it down that that's the thing that was causing issues. And if you take a look at an example heap down, you can see that, there were a lot of these beacons hanging around, and due to these opaque responses. So, yeah, and basically we filed a ticket with Chromium and they did confirm that it's a bug, they're working on it, but luckily there is a workaround. So basically you attach an abort controller, and that allows you to cancel any requests, any of these requests that are kind of hanging out. So basically the problem was like Chromium is hanging on to these promises, waiting for somebody to acknowledge them, but they never will be because they're in this special mode. So there's a workaround, so that's kind of great. And yeah, here's a heap dump after that, it's working. And the other really cool part about this type of bug, after a ton of work, a ton of effort, you actually get to see the benefit. Here's a QR code to follow the ticket and a survey. Seth, who worked on this primarily, posted it in the video dev channel. So let us know how you're firing these and if you're having issues. And if you do happen to see weirdness, check it out. Maybe this is it that's causing, crashes and your app running out of memory. Thanks.
And now for something different. Do you guys remember all the layoffs from 2 years ago? Or did you read that new grads in the past 2 years have not been able to find jobs? These are not just stories. Historically, the US tech sector has had 2% annual growth. This is good. Then we had the pandemic. Let's not talk about that. Then we're all going to Zoom in a metaverse. Do you remember that? But then what happened? For the past 2.5 years, something is off here. An economist would be alarmed. This is sector specific. The rest of the US job market is fine. We are in a sector-specific recession. What is causing that? Is it interest rates? Maybe. Is it pandemic overhiring corrections? Probably, but you already know about those, so I don't want to talk about that. Instead, I want to talk about Section 174. In 2017, Congress adopted the Tax Cuts and Jobs Act. This did many things, some good, and for example, tax rates went down, standard deductibles went up, But this was a revenue neutral bill. It had to be. So if something goes up, then something else has to go down. How did they do that? Well, you remember the salt caps, for example? Anyone? Anyone? But also, there were hidden tax increases built into the law that would take effect after 5 years. One of those was Section 174. So, Section 174 is normally for research and experimentation deductions for businesses. Isn't that exciting? Right? So this could be like biotech and things like that. 2 changes were made. One, in 2017, software development was added as a business expense that had to be covered under 174. And then second, effective 2022, you could no longer expense these deductions directly, but instead you had to amortize them or spread them over 5 or 15 years. What does that mean? Well, imagine that you have a company and you make $1 million, you have 5 engineers, they make $150K each, they pay personal taxes over that too, of course, and then $100K in other expenses. Your profit is $150K pre-tax. Then, before, that would be your taxable income, 21%, 31K in taxes, and that is your profit. Then after, you can only deduct 10%, which means your taxable income is 800, your taxes is 170, and you have a problem. This is worse if you're an LLC. This gets a little bit better in subsequent years, but it's a lot worse if you are in New York or California, where you pay local taxes also. In the worst case, you can end up paying 400K in taxes, over $1 million in revenue, not profits. And that is why we were all fired, because big businesses, they just fire and they pay taxes and it's fine. But small businesses, their margins are lower, their rates are higher, and so they can be in serious trouble. We have a functional government. They will try to fix this. They passed a bill to fix this in January, and it was rejected in the Senate. And so I need you to call your elected representatives and vote accordingly. Thank you.
Okie dokie. Slides. Oh, perfectly timed as well. So the talk is, I made a camera that we never used. Well, that we actually did use, because we did use it today quite a lot. If you've been watching a stream, you'll have seen it working. Why did I want to make a pan tilt zoom camera head at all? A bunch of reasons. One, if I walk over here, I'm no longer on the stream, because there's no one at that camera, there's no one at that camera. Yeah, the lighting apparently follows me. If I walk back over here, then I'm back on the stream again. So it'd be really cool if we could kind of keep that in frame. The other reason is I wanted some atmospheric shots of a ballroom with pans and tilts and zooms. That'd be amazing. I can't really afford a professional pan tilt zoom setup, and they don't really fit my cameras, and I like building things, and it was fun. Okay, ignore. So there's some prior art for this build. It was something I found on Thingiverse. The links are there. There's been 2 versions, and I'm going to publish a 3rd version instead. But this design needed a specialist bearing on it, which turned out to be quite expensive. Like, really freaking expensive. And it was a 3D printed version of the same bearing that I thought, oh, I'll give that a try. So I bought myself like 150 ball bearings and painstakingly put it together. While I sat at my desk, I got paged as I was putting together this thing. I jumped, and I still haven't finished finding ball bearings in my house. But it turns out you can get these little Lazy Susan bearings for really cheap. This is about 15 quid on Amazon UK. Adam Savage loves these bearings because you use them when you build R2-D2 robots. So you can get really big ones that you use for the head. So I went back and I modified the design, and I built this. A little pan tilt zoom head. You can see the updated bearing on the left-hand side picture. Here's a little video of it working. It works as a controller, which is here. Spoiler. And it kind of just drives itself. This is kind of the final speed I settled at. It's obviously driven by stepper motors, which have micro-stepping in them, so you're kind of making trade-offs of things like current usage, heat, and how smooth you want the pan tilt to be. And the first version just went so quickly, it just started spinning. Matt's seen all of these videos. It also sounded like a machine gun at one point, which was deeply terrifying. The camera that's on it is a Blackmagic Micro Studio camera Gen 2. It's small, it's got SDI, 12 gig SDI out, a lot of Micro Four Thirds lenses for it, which are ones I use anyway. The specific lens is this one, if you care. Very cost effective if you buy them secondhand, 200 quid, really good. But it has power focus and power zoom on it, which is actually really useful. I also built a camera control unit, or at least that's what I'm telling people it is, because anyone who actually works in broadcast would say, what the hell is that? It's a Raspberry Pi, then an Arduino stacked on top. The Arduino is really important because you need a real-time clock to control stepper motors correctly. Really hard to do on a Linux kernel. And yeah, that's kind of it. Also, do you see the symmetry? Yeah, what's in the box? What's in the box? Yeah, 10 years ago. There's also a bunch of software. There you go. There's also a bunch of software. I wrote the software on my left myself. It's what takes commands over a WebSocket, so you can control it from anywhere in the world, because it's actually on my tail scale as well, and then set the controls and uses the Gamepad API in the browser to pull from the stick values and write those down a WebSocket, which then goes down a little Go application that sticks it out a serial port. Then also, there's a little tool from Blackmagic that you can use just to control kind of all the ISO settings and everything, and then pan, tilt, zoom, the zoom control. Hopefully there's going to be a live demo. Look at that. Okay, so here's the demo. If I'm on the stream and I walk all the way over here, I disappear. But now, oh, it can chase me really slowly across. Come on, you can do it. You can do it. Oh, you're going the wrong way. There is actually a fast mode as well. Oh. Well, I'll just walk back over here. It's probably easier. Hey, there you go. So I promise it does work. So if you've been watching on the stream, it does actually work quite nicely. There's a little bit of tweaking left to do. Can I get the slides back, Justin, please? There you go. That was the live demo. To-do list, there's a couple of things that are broken. Zoom Focus is still on that app that Blackmagic provide. Well, it's actually an open source app, but someone wrote for the APIs that Blackmagic provide, I suppose. And on the controller, I've been kind of busy doing this thing over the last couple of weeks. The wiring is a bit of a mess, unsurprisingly. I want to scale it all up a bit because we've got these bigger cameras, but they're Blackmagic 4Ks, which are about this big as opposed to this big, so I need to scale it all up, big stepper motors if we're going to do the same for those next year, maybe. And then I've only half finished the software. But what is open source, and you can try it. Then I presume you're all going to complain. I used to do a lightning talk that's all VAV setup and everything. So you're going to ask me for a wiring diagram. Here is a wiring diagram. Yeah, I ran out of time. I'll put it in Slack later. Sorry about that. We did do some cool new things this year, though. One, we actually got some things in a rack for the first time. Do you remember we'd kind of got the lid stuck on top of a server because the cooler wouldn't fit? We finally got that in there. The relays downstairs are actually on a local network that is running over SRT, which is pretty cool. And then VLC playing the streams downstairs. And we're actually juggling the slides ourselves again. Justin is loving that. And there is Justin backstage. We are behind the video wall again in Video Village. 4 weird things have gone wrong this year so far. There's still time. Number one of our Mac Minis died on Tuesday night, I think it was. We put it in here, came in Wednesday morning. One of the HDMI ports just didn't work anymore. That was great. Thankfully, we had a spare Mac Mini, and then we went to the office yesterday and borrowed another Mac Mini just in case that one did the same thing. We had a short website issue. Justin told me I can blame him. To be very clear, pushed a little bit of JSON out, which just blatted all the streams, and we didn't have a backup of what that was. So yeah, we rolled that back. It was great. We've seen some weird timestamp drift still from this encoder. It's only this encoder that does this. I still have no idea what's going on. So I really need to sit down with this specific encoder to work out why we're seeing a little bit of timestamp drift. And one of the SRT clients on that little local network that literally has 3 machines on it drifted by about 30 seconds yesterday, and I have no idea why or how. I'm a little bit suspicious that someone paused it and then came back to it and it just ended up behind, but I'm not entirely sure. If you have any questions, find me, Phil Clough from Video Dev Slack. I'll happily answer anything. Might not be a good answer, but I will answer everything. And I want to say one big thank you to both Last Wave Productions, who provided loads of infrastructure here, as well as the whole AV team at the Regency for helping us out. It's been fantastic. Let's give them a round of applause to thank them for all hard work.